Hello guys, this is just question. We have to solve this one by one. Do it. This is the first question. A thin air film of thickness d is formed in a glass medium for normal incidence. The condition for constructive interference in the reflected beam is a thin air film. Let us say a thin air film like this. Thickness d is formed in a glass medium. This is the glass medium. Refractive index should be greater than 1. Here this is air 1, refractive index 1 for normal incidence. For normal incidence, we have to find the condition for the constructive interference. As you know, for constructive interference, path difference should be equal to m lambda, where m is equal to 0, 1, 2, dot, dot, dot. This is the thing. So here the path difference is due to two things. One thing is due to 2 mu t cos r. This is the thing for normally we use for the reflected surface, plus due to additional path difference, that is lambda by 2 uh, due to thick glass thick glass film, which is equal to this total path difference should be equal to m lambda. For normal incidence, r equal to 0, and here mu is the refractive index is equal to 1 for air, and t is the thickness, which is equal to d according to question. So put all this, that is will be the 2t is plus lambda by 2 is equal to m lambda. That implies d 2t is equal to m minus lambda by 2, m lambda into minus lambda by 2 equal to m minus half whole into lambda. This is the condition for constructive interference, and this is the answer, which matching with the option A. This is question 1. Let us see question number 2. Question number 2. A plane electromagnetic wave propagating in air where electric field is given is incident on a perfectly conducting slab position at x equal to 0. So electric field of the reflected wave. This is the incident wave electric field. We have to find reflected wave electric field. So as you know, in electromagnetic wave, E, K and B are perpendicular to each other. So E dot K is equal to 0. This is the condition for electromagnetic waves. K is the propagation vector, E is the electric field. Magnitude of amplitude of the electric field. So we have to check one by one from option in which E dot K is 0. Here this is the K, this is E. E dot K is not equal to 0. This is discarded. Option B. E, this is E, this is K. E dot K, which is equal to 0. This is matching, and this is E, this is K. This is also matching equal to 0. It can be the answer. And option D is not matching. It can't be our answer. So option B. In option B, minus 8 into 3 plus 6 into 4 is equal to 0. But we have to see whether it's the reflected wave whether it is showing a reflective wave or not. So k vector is equal to 3 I cap plus 4 j cap. E is equal to minus 8 I cap plus 6 j cap minus 5 k cap. So equal to 0. This is the normal incident electric field. Incident electric field is the propagation direction. This is propagation direction, which is 3 I cap minus 4 j cap. So our reflected wave should be like this. Minus 3 I cap minus 4 j cap. So k reflected is equal to minus 3 I cap minus 4 j cap. In which option matching? That is option C. So answer is equal to option C. Next question. Next question is two equal positive charge of magnitude Q separated by a distance d, surrounded by a thin, uniformly charged spherical shell, which radius is 2d, bearing a total charge minus 2q, and centered at the midpoint between two positive charges. The net electric field at a distance tau from the midpoint. So let us draw the figure. This is our spherical shell, which radius is 2d, and two plus q charges are situated like this at a distance d, and this spherical shell bearing the charge minus 2q. This is the spherical shell. So due to spherical shell, dipole is equal to 0, as we know. But we have to check one by one. First is the monopole. Monopole, sum over q equal to 0. Here monopole plus q minus 2q is equal to 0. So then we have to check dipole. Sum over p equal to 0. So q into d by 2 I cap plus q into minus d by 2 I cap is equal to 0. And due to spherical shell, total contribution of P equal to 0 due to symmetric case. So here P also 0. We have to, I can add next slide. As we know, if monopole 0 V and E, potential is proportional to 1 by R, electric field proportional to 1 by R square. If dipole 0, potential proportional to 1 by R square, electric field proportional to 1 by R cube. If quadrupole 0, potential proportional to 1 by R cube and electric field proportional to R power 4. Here are monopole 0, dipole 0, but quadrupole not equal to 0. So answer will be, your question is what is the electric field proportionality. So here electric field proportionality is 1 by R power 4. Let us go to the next question. Sphere of inner radius 1 cm and outer radius 2 cm, centered at origin, has a volume charge density K by 4 pi R. K is a non-zero constant and R is a radial distance. A point charge of magnitude 10 power minus 3 coulomb is placed at the origin. For what value of K, the electric field inside the cell is constant. So let us draw the figure. A sphere of inner radius 1 cm, outer radius 2 cm. A point charge is placed here, Q in, whose magnitude is 10 power minus 3 coulomb. For what value of K, the electric field inside the cell is constant. That means we have to find, this is the cell, this is sphere, this is the cell. So in here we have to find the electric field constant. So draw a Gaussian surface. At a distance r, find electric field. E dot 4 pi r square is equal to Q enclosed by epsilon naught according to Gauss law. So E dot 4 pi r square is equal to Q enclosed. Q in is already there. Q in plus integration of rho dV by epsilon naught. Q enclosed is given, that is 10 power minus 3 plus 1 by epsilon naught. Integration of rho is given K by 4 pi r, and this volume element is 4 pi r square dr. And the integration limit is from 1 to, as we are doing, from 1 to 1 centimeter to r. So this is 10 power minus 3 plus 1 by epsilon naught. This will be the K r square by 2. Limit is from 1 centimeter to r. So this will be the 10 power minus 3 plus K by 2 epsilon naught. R square is the r square minus 10 power minus 1 centimeter 10 power minus 2 meter, that is square, which is equal to 10 power minus 3 plus K by 2 epsilon naught whole into r square minus 10 power minus 4. I have to add one. Next slide. So here our total electric field is equal to 1 by 4 pi r square whole into 10 power minus 3 plus plus k by 2 epsilon naught minus 4. So to keep electric field inside is constant, so dE by dr should be 0. Okay, then we have to do derivative dE by dr. First simplify this, that is 10 power minus 3 divided by 4 pi r square plus k divided by 8 pi epsilon naught minus 10 power minus 4 k divided by 8 pi epsilon naught r square d by dr. So this will be cancelled due to constant. So 10 power minus 3 divided by 4 pi r cube minus 2 minus 10 power minus 4 k minus 2 divided by 8 pi epsilon naught r cube, keep it 0. So everything will common out, so that will be the 10 power minus 3 is equal to 10 power minus 4 k divided by 2, and this is 4 will be, so common and cancel out, so k will be 20. That's the answer. Let's go to the next question. This is a little bit long, but we have to solve this. This is very easy after solving this. Okay, consider a grounded conducting plane which is infinitely extend perpendicular to the y-axis at y equal to 0. If an infinite line of charge per unit length lambda runs parallel to the x-axis at y equal to t, then surface charge density on the conducting plane. Just draw the figure in the next slide. Infinite conducting plate. Infinite extend at y equal to 0. Equal to 0, this is like image method, and at a distance t from the y equal to 0, there is a line charge. This is t parallel to x-axis. This is x-axis. This is y-axis. Y equal to 0. That is the origin. Plus charge, that is lambda, and here due to this plus charge and infinite grounded conducting plate, so image of plus charge will be shown, so that is minus q. Minus q minus lambda, and at a distance minus t. We have to calculate potential. As you know, electric field due to line charge is lambda by 2 pi epsilon naught r. So potential will be minus lambda by 2 pi epsilon naught ln r. So potential due to plus lambda. Potential due to plus lambda is equal to minus lambda by 2 pi epsilon naught ln r. This is r plus potential due to minus lambda. This is minus of minus lambda divided by 2 pi epsilon naught ln r minus, which is equal to lambda by 2 pi epsilon naught ln r. So the total potential will be V total will be V1 V2 V1 plus V2 at a point. We have to find at a point. So total potential will be lambda by 2 epsilon naught ln ln, this is r minus ln r minus divided by, as we add the ln according to property of log, ln r minus by r plus will be. So extend this 4 pi 2 pi epsilon naught, and r minus is equal to, as y equal to 0, so y 0 keep, and there will be change in x and z. So sorry, along x, so keep x 0, so there will be change in y and z, but along y is line chart, so y r minus, that means minus minus plus r plus d, that is the position vector. We have to do by 1 plus z square divided by y minus d whole square plus z square. It's the thing. Sorry, this is not ln here. So we have to find surface charge density at on the plate here. So as you know, sigma is equal to electric field is equal to sigma by epsilon naught. So potential will be minus electric field is equal to minus grad of potential, so that sigma will be minus epsilon naught del v by del n. N is the normal to the surface, that is y. We have to derive by derivative, do derivative by y, del v by del y. Do this in the next slide. Potential is lambda by 2 pi epsilon naught ln sorry, I did little mistake. Here is the square of square. So to do it square, we have to multiply here another 2, that is 4. It's okay. Here this is 4 ln y plus d square plus z square by y minus d square plus z square. So del v by del y will be lambda by 4 pi epsilon naught ln derivative of ln is 1 by that factor. So 1 by is the, keep it change, then y plus d square plus z square into d by dy of y plus t square plus z square by y minus t square plus z square. Don't write it always, keep it as k. So k is into we have to do it in simple manner, so keep y plus t square plus z square into next to by n minus 1, that is y square into y minus t 2 into 2 and then plus y 2 derivative of this, so 2 into y plus t and then y minus t whole into square z square, that is thing. Put the value of k, that will be the cancel k, then put y equal to 0. As y is equal to 0 plane, there we have to find surface charge, so put all this y equal to 0. Our final answer will be lambda by 4 pi epsilon naught into 4 into 4 little wet into 4, sorry, minus sign will become here, minus sign is according to the formula, and if this is sigma, then epsilon would come also, minus 4 pi epsilon naught into, by solving, that will be 4t divided by z square plus t square. This cancel, so answer will be minus lambda t divided by z square plus t square. This is the answer. This is a simple question, don't do this very lengthy. Derive all this and put y equal to 0, we'll get this desired value. So let's go to the next question. An electric field E where k is a non-zero constant total charge enclosed by the cube as shown in the figure. Here this is the origin, this is the cube, its length is L. So we have to find the total charge enclosed by this cube. Let's say that is Q enclosed. Q enclosed is equal to integration of rho dV, as we know, and we know also rho is equal to epsilon naught divergence of electric field from Maxwell's equation. So find first divergence of electric field, which is equal to del by del x of k root x, and x cap dot x cap will be 1, and answer will be the k by 2 half in n to n minus 1, that is half into x to the half into x power minus half. So q enclosed in between here, starting from L to 2L, L to 2L. So integration limit will be L to 2L. First we have to do thing, that is k by 2 power minus half into dv. dv is equal to, here volume element dv will be L square dx, L square dx, and limit will be from L to 2L. So k by 2 L square common, x to power half by half, half cancel. So L to 2L will be k L square 2L to the power half minus L to the power half. By putting all this, k L square, keep common L per half, and this will be root 2 minus 1. So k L per 5 by 2 into root 2 minus 1. This is our last question. It's all over EMT question of Jest. Thank you. Thank you. Keep watching. Do subscribe and share.